So now we're going to switch the topic. So yesterday wasn't very practical because I told you guys of a lot of things that you can't really do the testing because it's expensive. But today I'm going to give you practical tips that you've all been kind of doing, but you didn't really understand why you were doing it during COVID. So let's start the lecture. Again, disclaimers: I own a research company, a genetic sequencing lab, and a foundation. Again, I always start with, if we knew what we were doing, it would not be called research. And Dr. Stolen and the future of disease. So I'm going to take you to Africa. And here, we're going to be seeing a lion, and we're going to ask ourselves, what makes a lion carnivore, right? Is it his microbiome that is craving the meat that's allowing him to digest? Does he have a microbiome specific to digest the food, right? Next up is our elephant. And if you look at the elephant, his dome, why is the elephant vegetarian? Is it the microbes in his gut that allows him to be vegetarian? So yesterday I kind of explained to you the dome of the elephant. Oh, good. So this was my guide. Remember I told you about. This is a dome of an elephant, and essentially when he opened it up, there were hundreds of ticks that were flying. Why didn't the guide have ticks? And by the way, after he finished with the dung of the elephant, he did not wash his hands, and he prepared my food and gave me my food. This is the art of refloralization. It's little amounts of bacteria given to you by someone that didn't wash his hands after touching a dung of an elephant. So, I'm not recommending it to anybody. You have to have a resilient microbiome for that. Otherwise, you're going to get ticks and Lyme disease. But anyways, the guide had spirochetes in his gut. The phylum that has Borrelia, that is your Lyme disease. So it's very important to understand that in order to understand Lyme disease, because the majority of patients do not, unfortunately, have spirochetes, especially in America. Nobody has spirochetes in their guts unless they've just gotten bitten by a tick. So now I'm going to take you to the Sahara Desert, where I collected stools of camels at 120 degrees in the middle of the temperature, and proceeded in catching E. coli, toxic E. coli from there. Again, why don't the Bedouins have E. coli? They're drinking the same ice cubes that I drank because they have a part of their environment. This is why when you go to a certain country, you are not able to tolerate their water. The locals are able to tolerate their water, but you're not able to tolerate it because you've lost microbes that recognize those microbes. Now, I'm going to take you to Alaska, where the iceberg is melting, right? And then we go to Argentina, where the iceberg is growing. So what is that? Why is one part of the world icebergs are melting and there's questionable global warming, but then on the other side of the world, the iceberg is growing and there's no global warming, it's cold there. So what's going on there? Interesting fun fact, which I'm going to talk about, bifidobacteria, the microbe that we're born with, decomposes plastic. So is it that some part of the world, this is by the way Argentina, is it that Argentina is not doesn't have as much pollution, let's say, as the north of Alaska, and is that why the microbiome is preserved over there that allows for iceberg to grow? So is global warming even a loss of microbes and a destruction of microbes? So something to think about. Now, this little girl survived COVID. She never got COVID. This is a poop from a cow. And this is what her dad makes her do every day. She's very healthy, very with it, and never got COVID. Why is that she's able to hold that? That's, again, the resilient microbiome. Now, on the other flip side, you have an HIV patient who eats a cucumber and gets sick. Why is that? Microbiome. So the microbiome tells the story, and it's going to tell the story through coronavirus. So coronavirus was actually a great opportunity for us to look at the stools. We were the lab that found COVID in the stools of patients, and it was kind of a funny story because my scientist said, you're spending $125,000 on stool samples to look for COVID, and you're not going to find anything. I said, well, if I don't look, I'm never going to find. Spend it, let's look at it. So on Friday, he calls me, he goes, guess how many samples have COVID in the stools? I said, I don't know, 5%? He goes, 100%. 100% of people that had positive nasal swab had COVID in their stools. And then what was interesting is that the virus itself was different. Do we have the pointer somewhere? It doesn't matter if we can. But what you'll notice is like you see patient 1 and patient 2. So this is this, oh, thank you. So this is the sequence of a virus. So when we're talking about finding COVID in the stools, we're talking about finding the whole entire sequence of COVID in the stools, not the PCR, which is a piece of the microbe. The whole entire, from head to body to tail, okay, and all its mutations. So this is the whole entire genome of patient 1, patient 4, patient 6, patient 8. See how they're all different? See how some of them are spiking because they have a lot more presence than others? So this already told us, wait a minute, this virus is mutating so fast. How can we even develop something to stop it, right? We need to kill it as soon as it comes. So if you look at the sequence, and this is the original, this was in 2020. Okay. Now remember, it went from Wuhan to Europe, to Japan, to Italy, then to America, right? By the time we got it in America, and by the way, I'm proud to say this was the first sample that came into America. I collected it from that cruise boat. Remember, they said, it's coming to America in a cruise. I'm like, get on that cruise, get me the stools. So sure enough, here it is. So look at this. The sequence has a bunch of 1A, like 5, 6, a bunch of 1B, 4 spike mutations already. 3A, 2, 1,8 nucleoprotein, okay? Now look at patient 1. You will see they have 2 mutations here at this location of the spike protein. Patient B has 3 spike mutations. Patient 3 has 1 spike mutation. How are you going to vaccinate someone and give them 1 spike when they have 3? You're not going to stop that. Remember, a vaccine is supposed to be matching the virus or the bacteria. Bacteria, it's much easier. And I think this is a concept that most people don't understand because if you don't do genetic sequencing, you don't really understand this. Bacteria has a process that when it mutates, it has a capacity to change the mutation, to capture the mutation and change it. In other words, bring it back to the way that it was. So bacteria, it's very easy to match a bacteria, right? Think about your bacteria that we've done vaccines in the past, right? Bacteria, you have a sequence is ABC. The vaccine is going to be ABC, slam dunk, easy, you vaccinate against the bacteria, no problem. A virus does not have the capability to reproduce and change. It doesn't have the ability to stop the mutation and repair the mutation. Therefore, when a virus replicates itself, right away it already replicated itself, mutated. And then the next time it keeps mutating, and the next time, and the next time, right? So basically what happens is you're getting a vaccine of ABC. The next time you're going to get a virus of EFG. Well, it doesn't matter that they're giving you ABC vaccine because that was last year's vaccine. It's not going to work, okay? So this is why it was important during the pandemic
to pay attention to this vaccine and to pay attention to what it was doing and to pay attention to the microbiome and to pay attention to the strains. The strains, they drove you crazy with the strains. We're on pangolin, we're on Delta, big deal. It didn't matter. What mattered what was in your gut that made you resilient to fight that virus, because the vaccine of yesterday was not going to be helping you. So now that I've kind of explained the case of how the virus mutates, and I'm going to kind of demonstrate one of the discoveries we made initially was we found the virus. So we said, well, if we find the virus, let's try to treat it. So we gave hydroxychloroquine to patients because that was the number one thing that people were saying in France. Dr. Didier Raoult said hydroxychloroquine, Z-Pack, vitamin C, D, and zinc. So, I jumped on that bandwagon and I said, let me look at what hydroxychloroquine is doing and azithromycin and zinc. So this was the baseline. The blue is the prior to hydroxychloroquine, Z-Pack, vitamin C, D, and zinc. And the red is after. The virus disappears with hydroxychloroquine, vitamin C, D, and zinc, and azithromycin. The only case where it didn't disappear was a full-blown AIDS patient. So this was an interesting finding because, again, is there resistance to treatment because of all the treatments that HIV patients have been undergoing? So this was an important finding. Here's the problem, and that became my protocol at the beginning of the pandemic. Most of you who have followed me on clinicaltrials.gov knew. Why did I take this protocol? One, because I saw that it disappeared in the stools, but then the other reason that I took the protocol, and I was kind of silly, I said hydroxychloroquine H, azithromycin A, Z, zinc, HAZ, first three letters of my last name. God is sending me a mission. So basically, that's what I took it on. What I learned, however, is that this was only a combination for certain people. Because unfortunately, as much as hydroxychloroquine kills the virus, it also kills your whole microbiome. So in the young people who have a strong, healthy microbiome, this was not a solution. The best solution became, let's look at what the stools of those people who survived COVID in the same, remember yesterday I showed you families are important and I like to look at the families. So if COVID is in the stools, what is it doing to the microbiome and what does the microbiome look like in COVID patients? So we took this paper that we published at the beginning of the pandemic. In fact, actually, we knew this data in 2020. It got only published in February of 2022. By the way, the first paper of finding COVID in the stools by whole genome came from our lab. We detected that in June of 2020. The paper didn't get published until January of 21. 6 months later, at a time where it's so important to know that COVID is in the stools, and it would have made such an impact because ask yourself, are people catching COVID because they're going into a bathroom where the virus is now airborne and you're getting into your nose? Does it even start in the gut? Then you have for those of you who have had COVID, the first symptom of COVID typically is diarrhea. Are you having diarrhea first, then are you breathing in that virus in your nose, then getting the respiratory infection? Possible. Are you going on an airplane and therefore people have COVID and go to the bathroom and now you're breathing in the fumes of the airplane? Possible, right? So this was an important finding to look at the stools, to look at COVID. Till this day, we are not able to do a diagnostic test with we're looking for COVID in the stools that's been approved by the FDA. They're not even paying attention to it. They don't want to know about it. This is not important to them. So if we look at the families, and we see the first column is a kid with COVID. Second column is a mom who was cooking, didn't wear a mask. Third is the son. So no one in the family wore a mask while this kid had COVID, okay? This mom has bifidobacteria. This son here had a lot of bifidobacteria, and his wife had a lot of bifidobacteria. This was the first sign of the importance of bifidobacteria protecting us against COVID. So So now I'm going to go to another family. We have 5 family members had COVID, and the baby had no symptoms from COVID. What did he have? Bifidobacteria. Remember, bifidobacteria, I'm going to keep saying it, that's your bacteria in your probiotics. They already knew the importance of bifidobacteria because it started way back 20 years ago with the whole movement of probiotics. So people knew bifidobacteria was important. So you could see the baby is protected because he's got a lot of bifidobacteria. From there, I decided to collect stools. So we collected 43 samples of severe COVID, and then about 20 of moderate, and 20 of high risk, exposed, but never got COVID. That's one of them is a senator in United States who's been very against vaccination and mandates of vaccination, and he's been exposed, unvaccinated, in front of everyone, going to rallies and everything. Never got COVID, so of course I collected his stools because I said, Senator, can I have your stools? I mean, you've not gotten COVID yet. And he's like, well, that's a peculiar thing to ask. So I said, well, this is important, it's for science. So anyway, those people, then there were doctors on the front line, paramedics on the front line, never got COVID, exposed to thousands of stool samples. My own secretary, manager actually of the lab, who collects stool samples. So we have a whole freezer in our lab with thousands of stool samples of COVID in the freezer. I say that's my nuclear bomb reservoir. So I'm like, please step into my lab. You're scared of touching the freezer? Come on. What's a little virus or 1,000 of them? So anyway, so there was my manager of the lab touched every single one of those tubes without a mask, never got COVID. She's in this group. Those are the people high risk, exposed, never got COVID. This is the lady in the back that's going to be my super donor, the patient of Dr. Lin. This is what I look for. So for all you doctors in the audience, any one of your patients, I'm going to give Dr. Lin my cards. Anybody that has not had COVID and is not vaccinated and you find their antibodies are still negative, send me the poop. I will pay for it. I will not charge anybody. I want to see that because those are your resilient microbiomes. Those are your preservation of what the Filipino resilient microbiome looks like, or Indonesia, or Algeria. It's important. This research is very important to preserve the microbiome of humanity because we're all different and we're all beautiful and we all complement each other. So it's important to know what is in our microbiome that makes us organized. What is in our microbiome that makes us happy, smiling? What is in our microbiome that makes us driven in agriculture, driven in business? It's all in microbes that make us who we are. How do I know that? Because you saw the case of the guy that was suicidal and I gave him the English professor and he became better. Same thing, you take happy person's microbiome into a depressed, miserable person's microbiome, you're going to change their personality. Personality is directed by what's in our gut. And I'm seeing that over and over again. Miserable people that come in, miserable, Alzheimer's. I change their gut. All of a sudden, they're happy. They remember their daughter's date of birth, etc. So bifidobacteria is very important. It took us 8 months to publish this paper. So it tells you about the corruption in science. So what is bifidobacteria? Other than a $1 billion industry. Actually, we're up to 15.58 billion, but it's probably going to be into the 100 billion industry of probiotics. And it's not only probiotics as pills, it's probiotic drinks, it's probiotics meat. I just saw a commercial today talk about the poop coffee. Now they have poop meat. So you can't even have proper meat anymore. It's going to be, processed poop in a steak. So yum. Anyway, so what is bifidobacteria? This is the mom. This is a newborn. See, the newborn is mostly bifidobacteria. We published this paper. This was a bifidobacteria against COVID-19, a mother and her newborn's gut microbiome. This is a very important paper. This was an anesthesiologist during the pandemic. She didn't want to get vaccinated, was pregnant. I collected her stools, her and the newborn baby. Because she was in the hospital, so she was actually, her bifidobacterial level was 1.5%. Then when at delivery of the baby, the delivery is stressful, so you're losing a bunch of bifidobacteria. Then she went up to 4.5%, and then somewhere along day 15, she ended up catching COVID in the hospital, took ivermectin and some major vitamin D, went up in her bifidobacteria from 4.7 to 19%, resolved her COVID. Now, what did the baby do on the other side? At birth, the baby has 0 microbes. The meconium has nothing. You didn't know that, right? I didn't know that either, because I'm thinking, oh, the baby's having microbes from the mom. As soon as the baby drinks his first drop of breast milk, the bifidobacteria starts climbing up. So you need, and by the way, there's no bifidobacteria in milk either, because I tested the milk. Strictly protein. So as soon as the baby drinks his first drink of protein, it lights up the gut to stimulate bifidobacteria. When the mama had COVID, the baby had 44% bifidobacteria. He had a sneeze, never was positive for COVID. Nothing happened to the baby. The mom kept taking vitamins, vitamin D, vitamin C, zinc. She actually was taking 4 zinc D a day. It's vitamin C, D, and zinc. The importance of giving good vitamins in the pregnancy, not necessarily just a vitamin, multivitamin, or folate, but giving vitamin C and vitamin D to increase the bifidobacteria. I'm going to show that. So you can see the baby is at 97% bifidobacteria. This is what your probiotics are made of. Poop of newborns. So this is important to understand where the bifidobacteria comes from. When you look at moms and newborns, you will see babies have a lot of bifidobacteria, newborns don't. It's important to understand bifidobacteria starts as a newborn with a lot, and we die with 0. When you start looking at people in a hospice or nursing home that are dying, they have 0 bifidobacteria. So the process of aging is really this loss of bifidobacteria. This is why your old people during the pandemic were dying of COVID, and your kids were fine, right? So I said before, biodegradation of microplastic, bifidobacteria decomposes plastic. So you know how people are telling you, oh, you have plastics in your gut, plastics in your brain, they found microplastics everywhere in the system. Well, because those people are lacking good microbes to decompose that. So who else has loss of bifidobacteria? Well, it turns out that patients with Lyme disease have 0 bifidobacteria. So whenever you're getting exposed to that tick, you're getting Borrelia, you're getting, Bartonella, what is happening? You don't have the defense to fight the microbe. Crohn's disease, also, if you look at patients with untreated, they have 0 bifidobacteria. People that are treated with Crohn's, their bifidobacteria climbs up, which begs the question, do these biologics actually do something to increase the bifidobacteria? And is that how people are improving? Invasive cancer, we're all seeing these turbo cancers. Well, we notice that invasive cancer is also loss of bifidobacteria. This is a very important slide. Remember yesterday I showed you the patient that I focused on bifidobacteria to treat? If you focus on increasing the bifidobacteria, then the cancer. So it's important to, unfortunately we're still in the world of, barbaric medicine of chemo drugs, where basically we're killing the tumor. It's all about kill, kill, kill. Maybe we should kill the tumor with the chemo, but then not forget to optimize the gut to increase the good bacteria to get rid of the tumor. Another loss of bifidobacteria and anxiety. All of you have treated COVID patients, and you know they were very anxious. They didn't want to take their medications. They were scared of dying. Is it because they have 0 bifidobacteria and high Bacteroides that cause that? So we published the differences in microbiome between anxiety patients and healthy. I'm at the level where when I see stools of patients, I can tell them, you're anxious, you haven't slept, you're foggy, you're slurred speech, and they're like, how do you know, doctor? I go, I see your microbiome. So the microbiome will eventually tell the story. Alzheimer's also is a loss of bifidobacteria. So your old patients that can't remember, that's probably why, and I'm going to show how we treat it, how we treat the bifidobacteria later. This is why your patients, that when you start nutritionally, giving them vitamins, then they start improving. You give them the right foods, the right honey, the right beef. They start improving with their memory. You're not just letting them decompensate. Another one is long haulers. Long haulers is also loss of bifidobacteria. And so unfortunately, you're not going to, if you keep killing and you keep giving antibiotics after antibiotics on these patients, you never let them grow. You never let them get back and pick up their microbiome. And that's why the long hauler syndrome, okay? And then lastly, autism is also, for the majority, obviously autism is a complex disease, but for the most part, a lot of them have zero bifidobacteria. And which makes you wonder, is that the beginning of autism? Are you killing the bifidobacteria? That kid that had 97% bifidobacteria, he's not gonna, we're following this kid. So we have a study right now where we're looking at newborns, and we're looking at the kids that have zero bifidobacteria versus the kids that have a lot of bifidobacteria. And we're noticing that the kids that have zero bifidobacteria are starting to become developmentally delayed. And possibly this could be the beginning of autism for these kids. That kid with the seizures, 100 seizures, that was bedridden on Depakote yesterday, that's a perfect example of, had I let that kid go, this kid would have become autistic in about a year or so. So what increases bifidobacteria? So for the vitamin C, where's the vitamin C lady? Do you want to bring her in? Because this is a key paper that we did for her. So vitamin C, you all know about vitamin C. You heard the lecture. You know that you take it, it improves viruses. That was always the treatment, right, for viruses. So we looked at vitamin C and bifidobacteria, and actually vitamin C increases the bifidobacteria. So this is something very important that you instinctively knew when you were giving people vitamin C, but in reality, in the patient, it does increase the bifidobacteria. This is again why the importance of a validated assay to look into this. So this is where collaboration is very important, and why we're all going to be starting to work together. When you notice something is working on your patient, it's important to get a baseline and then to see what changes. So for example, yesterday we heard about turmeric or curcumin IV. It's important, if you see changes in your patient, that their cancer is improving, to look at the microbiome before and after to see what has changed in the microbiome that the curcumin helped, right? Because this adds more to the formula of improving the gut. So we published this paper, vitamin C improves the gut bifidobacteria. The next thing was bovine immunoglobulins. Bovine is blood from the cow that you spin around, and it's the clear stuff that you give. And what we noticed is that actually increases the bifidobacteria. More importantly, it decreases the Bacteroides. Remember, Bacteroides was found in people with severe anxiety. It increases the Firmicutes. There's a lot of patients, especially with neurological problems, that have low Firmicutes. So if your formula of your microbiome is loss of bifidobacteria, high Bacteroides, low Firmicutes, and high Proteobacteria, bovine immunoglobulin is the answer for you. That's your patients with Crohn's disease, irritable bowel syndrome. That's why bovine immunoglobulin is actually important in inflammatory bowel disease. And for the lady that was talking to me yesterday about ulcerative colitis, this is a good go-to drug for me, bovine, to improve that. Ivermectin. Well, ivermectin was a great discovery during the pandemic, because what is ivermectin? It's the product of a bacteria called streptomycin, which is basically the same phylum or group of microbes as bifidobacteria. So essentially what you're doing is you're giving bifidobacteria, and so you're seeing it increase. Here's the problem with ivermectin. It only lasts 24 hours. So you have to keep supplementing it. Not a great long-term value. It is good for short term. It is good if you're trying to increase the bifidobacteria, possibly to help that cancer. That's probably why it's helping in certain cancer cases, because they need all the help they can get to increase the bifidobacteria for their cancer. But it only lasts 24 hours. So you've got to be very careful to go slow to go low and not to create a resistance, and also not to overdose these patients, because there's so many things we don't know about ivermectin long term. But this is what I observed during the pandemic. My patients with hypoxia went from 73%, and after 36 milligrams of ivermectin, oxygen saturation went from 73 to 95%. How does that happen? So we published this paper, Effectiveness of Ivermectin-Based Multi-Drug Therapy in Severe Hypoxic Patients. That also took about a year to publish. What is the hypothesis there? The hypothesis is if you've got these cytokines here in your gut, and you've got some bifidobacteria, they grab onto the cytokines. If you've got a lot more cytokines than bifidobacteria, then you're gonna decompensate. The problem is in the lungs right now, you've got all these cytokines in the lungs, cytokines in the colon. You don't have anything to grab those cytokines. Now you give ivermectin, you increase the bifidobacteria. Here, they bind to your TNF-alpha, they bind to your cytokines. You now have the patient having diarrhea, releasing all those cytokines. Now the blood is circulating from the lungs to the colon. They can breathe again. Oxygen gets back in the lung because now they've removed. One of the greatest studies that ever was done, and actually it was done in China, where they gave patients bifidobacteria implant, and they noticed that their asthma was improving, their COPD was improving. Why? Because everything circulates from the colon to the lungs, to the brain, to everything circulates. So this is an important ivermectin increases. We published this. By the way, I published a hypothesis before I knew the data on this, and it was the most read during the pandemic, and it was retracted. That's when I knew corporate America had taken over medicine, and I knew I was going to become a warrior and not a scientist. So here we are, our role of probiotics. Now everybody will say, well, bifidobacteria, it's simple. I killed my Biff. Let me take some probiotics. Simple, right? Wrong. Why? Because unfortunately, the questions you should be asking is the label real? 17 out of 18, or actually 16 out of 17 probiotics on the market that say bifidobacteria do not have bifidobacteria in them. Nobody is supervising the labels of those probiotics. Worse, it has other junk in there that kills your possible bifidobacteria. The second thing you should be asking, remember, bifidobacteria is anaerobic. It doesn't breathe oxygen. Is it alive or is it dead? Because if it's dead, why are you putting a dead bacteria in a gut that's alive? It's like living with a bunch of corpses. You're going to pretty much become a corpse yourself. And then the next thing is, are you stopping your own ability to grow bifidobacteria? For example, you take pancreatic enzymes. You're shutting down the ability of the pancreas to stimulate pancreatic enzyme. What happens then? You become dependent on the pancreatic enzyme. Your pancreas is shut down, and eventually you end up having chronic pancreatitis and seeing me for pancreas problems. So it's very important to let our bodies do what they're supposed to do, which is grow those microbes, grow them with nutrients, with the right stuff. And then the last thing, and the most important thing with probiotics, does it implant? I have over 4,000 stool samples of patients that have been taking probiotics, and I can assure you, in them, there's no bifidobacteria in their colon. Why is that? You expect this little pill full of microbes, dead or alive, to travel the stomach, where it's very acidic, to the small bowel, not break out in your small bowel, and then end up in your colon, in your cecum. That's almost impossible. So you can take all the probiotics, but the reality is they're not going to get to where they need to get. So probiotics, and I'm going to show some data that we published, impact of probiotics on the gut bifidobacteria. These are the people that took poor quality probiotics that were actually dead probiotics. You can see they have zero bifidobacteria. We have a lot bigger sample size right now. And then these are people that actually took regulated probiotics, that they've done the study, their quality, it hasn't gotten exposed to arsenic or silica or other things. They actually have a good level of bifidobacteria from the probiotics. So when I see a patient that's on a probiotic, I never remove the probiotics when I test the microbiome because I want to know, is that probiotics doing something, right? And remember, we're able to see the species. So I'm able to match the label with the poop. So if the label tells me bifidolongum, bifidobifidum, bifidobadolescensis, or infantis, I should be able to see it in the colon of my patient. Vice versa, if I see if I'm giving the patient bifido infantis and I see bifidolongum in my patient, well, why am I giving him bifido infantis? It's not even in the colon. He's developing his own bifidobacteria longum. Let's just focus on growing that bifidolongum. So it's important. And these are people basically that were taking no probiotics and were healthy. So the other big question, and I killed my bifidobacteria during the pandemic because that's what I did. I was the guinea pig. And what I realized is I started drinking kefir because I said, well, my kefir has a lot of bifidobacteria. It says so on the label. So I'm testing my stools, and I'm noticing that my bifidobacteria that's in the label of kefir is not in my stools. And I'm drinking like a gallon of kefir a day. How do I not pick up bifidobacteria from my yogurt, from my drink? So I decided to test the kefir. Lo and behold, there was no bifidobacteria in my kefir. Well, I could drink 2 gallons of that. So I decided, well, no wonder my patients are not getting better. I'm telling them to drink kefir. Sorry. Oh. So I went to the grocery store in Malibu, and I decided to take, 26 products. And out of the 26 products in my local store, only 3 of them had bifidobacteria in there. The other 26, that means your drink that says bifido drink, wrong, there's no bifidobacteria in there. Worse, a bunch of them had streptococcus. One of them had B. cereus. If you know anything about B. cereus, that's the bacteria you get when you leave rice over the counter for a while and then you get vomiting and diarrhea. One of them had B. cereus in it. So this is unfortunately the product. And I never really, busted all these companies because I said, well, I'm not a sheriff. It's up to the FDA to bust this. But clearly nothing's been done about this. So this is a serious problem that you have to be vigilant even of your products. So what kills the bifidobacteria? This is why I became like a target for everybody. Unfortunately, your messenger RNA vaccines kill the bifidobacteria. How do I did this study because at the beginning, remember, everybody was rushing to vaccinate, and everybody was forgetting about treating. Why did we vaccinate and not treat at the same time? Why did we stop treatment and vaccinate? That was ridiculous. You should turn off the fire and then look back and say, okay, well, this is what I used to turn off the fire that worked. Instead, one narrative, one push. So I decided to look at all the doctors before and after vaccination, before they went to work. Remember, all the doctors were at home and they were basically quarantined. And I said, can I have your stools at baseline at home? And then can I have it after a month of being vaccinated? And lo and behold, we discovered that bifidobacteria dropped by 50% in these doctors. More importantly, so you could see before and after vaccination, the drop in bifidobacteria across the line. But more importantly, 9 months later, the vaccine, the spike protein, remained in the gut and kept killing the bifidobacteria. Which then asks the question, is this a bifidophage? Is this why when the person gets vaccinated, they go home and then a month later they get COVID? Are you killing? You were fine the whole pandemic, and then all of a sudden you get COVID. You never got COVID. You were exposed to a lot of patients. All of a sudden you get vaccinated. Did you kill your bifidobacteria and then catch COVID? And is that why? And by the way, this is why everybody started questioning this vaccine. It wasn't Sabine Hazan came out with this data. People were noticing it themselves. They were like, wait a minute, I'm supposed to take this vaccine and now I have COVID. Isn't that the purpose? But then they changed the narrative on you and told you, but at least you didn't die from COVID. Well, you didn't die from COVID before then either. So I'm going to go back to my paper, The Island of Research. The graph, one rule, do not block the path of inquiry. So here's the problem with blocking the path of inquiry. Nobody really knows what hydroxychloroquine does to the virus or to the microbiome. Nobody really knows what ivermectin does short-term or long-term, right? This is all data that needs to be out there because science is a foundation. I add a brick, someone else adds a brick that has a different experience, and another person adds a brick, and pretty soon you have a beautiful building that was developed by everybody adding their information on science. So the big crisis that I'm seeing, over 1,000 samples, in fact, out of 1,000, one patient has lactobacillus and lactococcus in their gut. Out of 1,000 samples that we analyzed at Progenobiome. And less than 5% have an adequate amount of bifidobacteria. So if we think the answer is going to be fecal transplant in the future, because everybody comes to me, oh doc, I want fecal transplant for this and this. Good luck finding your donor. And that's what I tell them. Who's your donor? Because if your donor doesn't have bifidobacteria or lactobacillus, good luck. What is lactobacillus? It helps us absorb calcium. What is bifidobacteria? It helps us absorb sugar. What are we if we can't absorb sugar or calcium? What are our mitochondria doing? What is the Krebs cycle doing? Do we wonder why these patients are chronically fatigued? They can't get out of bed. They're not able to metabolize sugar or calcium. So I'm going to finish with Albert Einstein said, because I'm a big fan of Albert Einstein, who was a very humble man. If the bee is, even though he started the whole nuclear bomb, which, sometimes if you have an experiment that's going to kill things, it's better to leave them in a closet, I think. Not all experiments should be developed, in my opinion, and we should only develop things that improve humanity. So because here's the thing, what is the nuclear bomb doing? It's killing people on one side of the world, but do we think it's not affecting people on the other side of the world? The nuclear radiation, they pass the planet, they go on the other side. This is why people in San Francisco, after Hiroshima, people in San Francisco started having a lot of cancers. Did it pass? Every war, every bomb, every nuclear is affecting the microbiome of the planet. Every pesticide we sell and we push on our soil is going into the soil and is killing the microbiome. The microbiome of humanity is disappearing. This is why I'm here. This is why I'm doing this lecture. We need to pay attention. So Albert Einstein said, if the bee disappeared off the face of the earth, man would only have 4 years to live. So let's explore the bee, shall we? What is the bee? The bee actually uses sugar and water, and it basically goes from tree to tree and pollinates, right? And then it secretes this beautiful honey that we eat, which is a good sterilizer for us. And then it swallows things and it has microbes. What is in the rectum of the bee? Lactobacillus and bifidobacteria. The poop of the bee is what goes onto your fruits that allows for fertilization of your fruits. So really what Albert Einstein meant to say is if the Biff disappeared off the planet, men would only have 4 years to live. And I agree, because we are at a crisis right now. We are seeing the disappearance of bifidobacteria and lactobacillus, and this is something I take seriously. So again, I could be reached, and now I have a lot of time to ask questions and answer. And hopefully I enlighten you onto what you're doing, practicing the art of medicine actually may have a foundation in the microbiome, and you may be helping these patients become resilient in their own way. And that's the most important thing we can do as doctors, is give faith, give strength to our patients, let them be warriors to develop their own strength to survive. I think one of the reasons I lost no one during the pandemic is because I was the soldier. I told the patient, take this medication, don't listen to the politicians, or you're going to die. That's it. I don't want to hear any cries or victimized. You're a warrior now. You're going to warrior up and you're going to survive. And thousands of patients later, no one died on my shift. So we have to be the soldiers for our patients as doctors, right? And that's it. So, thank you.
We have 10 minutes to give all the questions. I mean, it's such a very beautiful lecture. You're such a beautiful person.
Thank you.
And thank you for being a hero in this COVID
Well, I'm surrounded by heroes too, so thank you, all of you.
This is just an amazing lecture. I learned so much from it.
Pleasure.
I will get also some information, and Mike and I be the first of class.
Yes.
From yesterday, I've been wanting to expand on her question. I think, and maybe it's something we can actually look at, the nurture versus nature of the microbiome for those that we care for, the babies that are not really ours, but seems like perhaps later on the microbiome will have some genetic or some DNA or whatever sequencing that may be similar, just because we're the primary caregivers of these babies that are not biologically from our womb.
Yeah, and I think supporting nurturing is so important, and supporting these babies and making sure they have proper vitamin D is definitely the number one in newborns. So I think we don't test the vitamin D level of the pregnant woman or the baby, and it's so needed. Because I think the majority of postpartum depression women are low in vitamin D. And same thing with these babies that start off with autism, probably that could have been intercepted. Yes, they could have gotten something that killed their bifidobacteria, but there's no reason that to supplement. You know, you're not going to stop people that are just going to do stupid things, right? And unfortunately, we are in a path of, corporate America trying to push one thing after one product after another. So it is going to kill, to a point, these babies. So our job is to optimize, to know that, you're going to have an injury because you're going to be getting something that you didn't anticipate in getting. Maybe optimize the gut with extra vitamin D. That vitamin D is probably the most important thing. So, and the fact that they stopped it during COVID was a big red flag, because that's ridiculous.
Thank you. Now for our official first question of the day.
Thank you. Dr. Chan here again from Rwanda, Malaysia. Good morning, everyone. My name is Dr. Sabine. So you mentioned that vitamin C and ivermectin increases beta. So my question is why? Is it because it will cure all the harmful pathogen like COVID? What is the mechanism for that?
I think the mechanism with vitamin C is it's really a nutrient for the microbes, kind of like sugar is a nutrient, kind of like protein. Remember breast milk of the mom I showed you with the baby that increases the bifidobacteria? That's probably why also your peptides are working, right? Are they increasing bifidobacteria at some level? So I think that's the number one, is it acts as a nutrient. Ivermectin is not a nutrient. Ivermectin is the product of a bacteria. And I think what happens there is it feeds, that secretion feeds the bifidobacteria to grow it. The secretion itself. Remember, all these bugs secrete, byproducts, right? So these byproducts help each other. In the world of the microbiome, it's which microbe is helping which microbe to fight this microbe to keep the balance, right, in the microbiome. So even viruses, they play a role up to a point. I was just texted by a patient of mine today who got COVID, and prior to that, he had the worst irritable bowel syndrome where he would go to the restaurant and get diarrhea. After COVID, his problems are gone. Why is that? Because probably the virus acted as a bacteriophage for the bacteria that was causing him the diarrhea to begin with. So even viruses can have a role in therapy, but again, the battle is between microbes in the gut. And so our role is to give the right nutrition to those microbes rather than giving them other microbes. So I'm a big pusher of nutrients, of vitamins, bovine, the right beef, the right protein, the right peptides, because that's the nutrient you're feeding the microbe, right? It's like a garden that you're just giving nutrients. I'm not a pusher of more microbes, because the problem is then you offset the balance, right? Is that bifidobacteria, was that supposed to be for you? And here's again the difference, of different races, right? If you look at the Amazon jungle, The Amazon jungle don't have any bifidobacteria, it's another microbe. The Chinese, bifidobacteria is not the most important. It's Collinsella within that phylum. That's really the microbe that seems to be prominent in China, right? So different races have different microbes that are prominent. This is a study in America. America is big on drinking milk and cow milk and milk products. So bifidobacteria has a huge, and breastfeeding, etc. Bifidobacteria has a huge presence in America. Is that the same presence in other countries? I don't know. That's why we need to look at the normals in the Philippines, the preserved microbiome in the Philippines, the preserved in Algeria, in Switzerland, in Malaysia. It's so important to get that signature microbiome of what does the culture, what does the race look like, to preserve that identity, because we as a planet have different microbes that we house, but because of different reasons, right? We all have a job. To think that we're coming to this planet for us is ridiculous. Maybe Bill Gates thinks that, but the rest of us, we believe we have a job, right? Much like the bees, they have a job. Their job is to pollinate, right? So if we have a job, we are given what we are, the tools through our microbiome to do that job. So it's important to preserve the diversity of the planet and the diversity of the races. And this is why I'm very big on don't eat the McDonald's and the Kentucky Fried Chicken that makes you American. Stick to the culture and the foods of the Philippines to keep going that, or foods from Malaysia, because you are born with a microbiome. You're not only born with the microbiome, but you're born with genetic predisposition that allows you to adapt to that microbiome. It's not, when we do fecal transplant, it's not just we're changing the microbiome, but we have to also take in consideration the colon receptors that attach these microbes. So that's another piece of the equation.
Thank you. In terms of nutrients, they are called prebiotics.
Prebiotics is very important. Yeah, that's the bed, that's the fiber.
And recently, they're also called postbiotics.
Postbiotics, yes.
And what was the difference?
Yes, so probiotic is basically your colostrum. It's your protein. So the prebiotic is your fiber. So they've made all that very fancy, right? But in reality, it's your prebiotic is the bed where your microbes are living. It's the fiber. The postbiotic is the protein and the colostrum, the breast milk. But it's an American way of selling, products. But really, it's food we're talking about.
So going back to, so before I ask my question, there was a small study. They gave breast milk, milk with 3.5 milligrams of mother's poop in cesarean babies. By the second day, their microbiome is similar to those at vaginal delivery. So I think that's kind of interesting. That just came up. But really, my question would be, if you say that the kefir doesn't have bifidobacterium, so even milk, would milk have bifidobacterium?
No, milk doesn't have
Unless it's raw, right?
No, not even. So milk, even breast milk, remember, breast milk doesn't have, it's just protein. But remember, the protein stimulates your own ability to make bifidobacteria. So you don't really need that's why people that eat yogurt, they do fine. It doesn't need to have bifidobacteria added to it.
Okay. And then second question, because of the pandemic, a lot of Filipinos were taking ivermectin because it, literally healed them from COVID.
Mm-hmm.
So afterwards, what the Filipinos did was they were taking ivermectin once or twice a day.
Wow.
They swear.
Yeah.
And I've seen them, they swear, their allergies gone, their autoimmune disorder gone, rheumatoid arthritis, everything gone. So now, ivermectin is like a drug for everything.
Yeah, but the problem is at some point when it's gone, you gotta kind of stop it, because then you become used to that, and then we don't have data on long-term effect of that. And resistance, that's the most important, because that was the problem, right? What happens when the next virus that they fabricate becomes more virulent? Now you've been taking ivermectin, what are you gonna give it next? to kill it. So I think for those people that were taking ivermectin, it's time to resort to going back to vitamins and then slowly kind of getting to a regular base of vitamins. So what I do is for those people that want to know, is I wean off the ivermectin, I wean off the drugs, and I push the vitamin C, D, zinc combo. I add the vitamin B, I add the magnesium, kind of what you were talking about yesterday. And then I do that for about a year and a half, because it takes about a year and a half to restore the microbiome. And then I start weaning off the vitamin C, I start weaning off the zinc, I maintain the vitamin B, I maintain the magnesium, depending if they have a bowel movement, if they're constipated. If they're not constipated, I don't. And then my goal is really to keep them on vitamin D and a good nutrition and bringing them back to, you don't want to be dependent on vitamins, you don't want to be dependent on drugs. You want to live a normal life where you're dependent on good food and happy life and not fearing having the next virus. So.
Anyone, any more question? Because Dr. Sabine will be leaving after this talk, just to fly to El Nido.
Yes. Poor me. I figured I came all the way, I might as well see it.
Yes,
But I'm going to give my cards. I encourage anyone who wants to work with me with doing stool testing, you have a product that you feel has been working with your patients, you have interesting cases, send me an email and say, look, I have this interesting case, I really would love to see the microbiome before and after. And we can together, write the data and explore. And also if you have zero COVID, non-vaccinated patients that are healthy, like the young lady in the back, that was my big find of the weekend, please send them to me because we're looking for those patients, okay?
Okay, thank you.
Thank you very much.
I also try to give you this. This is a probiotic from Japan, 10 years fermented with kefir.